All right, everybody, we got another problem here about the partial pressure of CO2 in the atmosphere, and it's asking us to use Henry's law to calculate the solubility of CO2 in the ocean if the partial pressure of CO2 in the atmosphere were to double. So it's giving you a setup, it's telling you what the CO2 is, what the CO2 partial pressure is currently, what the molarity of the CO2 is in the ocean. That's understood to be the solubility currently. And so we're going to need to bring in Henry's law, and Henry's law says that the concentration of a component is equal to Henry's law constant times the partial pressure of that component. Now, what the problem doesn't give you is it doesn't give you the Henry's law constant, but it does give you enough information in order to solve for that. So if you take the partial pressure and you use that to divide, if you take the concentration and you divide that by the partial pressure, you'll get the constant. And so that's 1.60 times 10 to the negative fifth molarity over 0.5 millimeters of mercury. And so that comes up to 3.2 times 10 to the negative fifth molarity per millimeter of mercury. Now that we know the constant, we can solve for the concentration under the new conditions. So 3.2 times 10 to the fifth molarity per millimeters of mercury times the concentration, the partial pressure, if it were to double. So 0.5 millimeters of mercury times 2, you get 1.0 millimeters of mercury. And so millimeters of mercury cancel with millimeters of mercury, leaving you with a concentration of 3.2 times 10 to the negative fifth molarity. And so that's understood to be the maximum solubility at that point, because CO2 will be at its solubility level based on the partial pressure of the gas in the atmosphere. So that's the final answer. Okay,